Welcome back, everybody. Last lesson of the trimester. Boy, is it a doozy. So, jumping right in, we're going to check out some of these formulas and how they work. This is all that we have, right? This is just finishing off that first note page from the volume stuff. And surface area gets complicated because depending on the shape, you have to find how much space all the sides are when added together. How much space does all that cover? Not just what fits inside, but we basically end up adding all those sides together. And originally, I was going to have you do it that way. I was going to have you make nets, find the area of each side individually, and boy, oh boy, was it time consuming. So I decided to introduce at least these more complicated formulas that save time. So the big trade-off here is that we have some real complex looking formulas we're working with, but they're real efficient about getting you the answer. Like in order to peel a cone apart, you actually end up with a circle and then kind of a weird looking shape. It's not fun to try to find the area of something like that. So these formulas will do that for us and make it pretty easy and convenient, but they're complicated to use. So bear with me, and I've tried to lay it out as clearly as possible for you. So if we're working with a prism, we can use this formula P times H plus 2 times B. And well, if you're wondering what the heck that means, P is going to be the base perimeter. So we're going to remember bases are the sides that there's two of them congruent. It's not just the bottom, but bases are the congruent where there's only two congruent sides. So since the top, bottom, front, and back, there's four of those that are all the same. Those are not the bases, even though it looks like that's shaded. Isn't that the base? It's the bottom. No, the bases are the ones that are congruent shapes. Here, the bases are the top and bottom, right? Those triangles. There's 1, 2, 3, the left-ish, right-ish, and back sides that are the other faces. These are the congruent bases. Those are the two congruent sides that we call bases. Same thing here. The trapezoids are the bases. The other sides are not. So the P is going to be the perimeter of a base. So I've got to go around a base and find that distance. Once I know that, I can multiply it by the height, which is the other direction. So this would be the height. This is the base. And then I add on 2 times the base area. So I go back to that idea of base and I multiply the area out on that one, right? I told you, complicated. It's a lot of little pieces, but it's so much faster than trying to find the area of these trapezoids and the area of all the sides. It's really time consuming to do that way. So learning how to use complex formulas is a good thing before you get into Algebra 2 next year anyways, because, stuff gets wild in Algebra 2. You literally learn about things called imaginary numbers. Good luck. On a cylinder, right? Circular cylinder, we have 2 times pi times the radius times height. That's pretty simple, right? The radius just goes out. The height is how far up. And then we just use the radius again. So the only thing we have to worry about there is radius. Same thing on a sphere. All we have to worry about is radius. Those circular boys are actually kind of nice to work with. We will need to be, familiar. This is what it really is this is taking the circumference times the height, and this is taking the area times the height is what you're really doing there. It's kind of an interesting if you break it down, but interesting, to me, but probably not so much to you. Okay, back over here we have P, which again is the base perimeter. So on a pyramid, the base is that bottom part. So we need to find the perimeter around it. L, now, L, this is a new idea. Well, I mentioned it last video, but the L is the slant height. It's this diagonal. It's not the altitude, right? Altitude is different. That measures from the vertex straight down to the base. The slant height measures along this diagonal. And so what's going to happen is we're going to make a right triangle there, and we're going to have to use some Pythagorean theorem business to find our slant heights. So then the base area, again, is just length times width down here to find your area. But that slant height is going to come in on both the regular pyramid and on the cone. We're going to have to do the same dealio, where we find the altitude and the radius and use those to find our slant height, that L, the slant height again. So let's put this to work. If you'd like to, try to pause the video and try the first cylinder one. It's not too bad. Cylinder's just the height and radius, which you've got both, the height and the radius. But we have a different formula, notice, than we were working with last time. If you think, hey, those are the same shapes as last one. Yes, but we're doing surface area, not volume. We're looking at how much it would take to paint the outside rather than how much will fit inside, right? That's the difference. So if you'd like to pause and try it, go ahead. But just try the first one, and then I'll introduce some stuff on the next couple as well. All right. So first I identified the radius is 15 and the height is 10. That might seem really silly here because, it's already labeled. I can't stress enough how useful that is to take a minute and write those things out, because when we start getting all these extra things with the pyramids and the cones, or even in the prisms, it's so nice to have it right there. That way, when I went to use my formula, 2 pi, hey, there's a variable, r. Well, I just replace r with what I wrote next to r, 15, right? 2 pi 15 times h. Hey, h is 10, so I replaced h with a 10, plus 2 pi times r again, 15 squared. And then it's literally just typing into a calculator. Like, all this is getting organized and replacing the variables with the appropriate number and typing it into a calculator. That is it. So when you let the calculator crunch, we've got pi in there, so we're going to get an about, right? Pi goes on forever, so I had to round. And we have 2,356.19 square millimeters. So we are back to square, not cubed, like the last practice had all three exponents, because we were actually filling up a three-dimensional space. Remember, I could cut this thing open and lay it out flat as a net. That's just a two-dimensional space. When we're talking about surface, even though it's a surface of a 3D object, we're only worried about the flat sides of it. We can lay this out in a two-dimensional space. I could take a cylinder and lay it flat. That's the idea. So we're back, whenever you're measuring any kind of area, you're always working with square millimeters, square inches, square meters. Whenever you're filling volume, you have to have a three-dimensional space. If you laid a surface out flat and then put water in it, it's not going to work very well, is it? Right? You need 3 dimensions in order to have volume. Whenever we're talking surface area, you only need 2. So there's that. All right. The next one is a triangular prism. So we're going to be using this formula up here for a triangular prism. Use those shapes to help you figure out which formula to use, right? Pyramid, triangular prism, cone. That weird dude we're going to have to split apart again, right? So if you'd like to, you should go ahead and pause the video and try the rest of them. I just realized my numbers are all screwed up. I promise you I know how to count. 2, 2, 3, 5, 5, 6. What? Sorry. Try the other 5 problems that are here. Do your best. It's the lowest of stakes. There's no penalty to missing these. It's just you trying to figure out how this stuff works, how to use these formulas. It will be much more beneficial if you try to pause and work through them and then look at the answers rather than just watching me do them in a second. So pause now, see what you can do. Whew. First and foremost, if you work through all that, congratulations, you are a champion. That is a lot, right? Surface area is so much more cumbersome than volume. You got to break apart the pieces of the equation and take care of them one by one before you plug them all in. So let's check out how this works. We're going to be using surface area of a prism, so we need to find the base's perimeter, the height of the thing, and the base's area. Those 3 pieces before we can plug them in. To find the perimeter of this base, remember the base is the one that's got 2 congruent sides. So these 2 pieces right here, right? These other rectangles are not congruent with each other. These are the 2 bases. So I need to find the perimeter of one of those. Well, I've got 1 and 2, but if I want to know this perimeter, I have to do Pythagorean theorem, right? It's a right triangle. So 1 squared plus 2 squared equals this side squared. And if I square root that, then that gives me the side length. So it's about 2.24 is our side length there. Well, then I just add those numbers together. 1 plus 2 plus 2.24 to get the perimeter. So that's what I'm going to use for P is 5.24, the sum of those three sides. The height is easy. It's just this one right here, 6. The base area is, again, working with this triangle. I need to find the area of that base. Well, the area of a triangle is base times height. So 1 times 2, and then half of that, half base times height. So half times 1 times 2 is just going to give you an area of 1. That's nice. We actually saw that in the last one, I think, as well. Well, we've got all our pieces now. We've got the perimeter, we've got the height, and we've got the base area. So we just plug those in to the equation. We have the perimeter times the height. So 5.24 times the height, 6. We multiply those together and then add on 2 times the base area plus 2 times our base area of 1. Again, just calculator work at this point. You type that in, boom, there's your answer, 33.44. Pyramid, we're going to have to find slant height. Whenever you're working with a pyramid or cone, you need that L, the slant height. Not sure why it's an L. It is what it is, though. It's usually a cursive L. You'll see me write them as cursive. That's just habit. I couldn't get the equation editor to do that, so you just got basic L's in the equation. But anyways, to find the slant height, again, we're going to use Pythagorean theorem. But here, you're going Pythagorean theorem from the altitude, which drops right down into the middle of that square base. So we're only going to use half of that base. If you got that right, holy crap, you're a champion. That's amazing. You actually probably Googled something, but that's awesome too. Good job using resources. So you're going to use half of that side length, 3, with the altitude 4 to find the slant height. 3 squared plus 4 squared is 25. Square root of 25 is 5. So the slant height is 5. Did you catch that? Set up this right triangle that has a side of 3 and a side of 4, and we're looking for the hypotenuse. So we go a squared plus b squared equals c squared. 3 squared plus 4 squared would be 25. That's this side squared, so I square root it to get the actual side length. So square them, add them, square root them to find the slant length. It's 5. Your base area then is just length times width. 6 times 6 is 36. And now I'm ready to plug all my information in. Half. The base perimeter would just be moving around the outside. I think I skipped that part when I was going over it. The perimeter would be 6 plus 6 plus 6 plus 6. You need the base perimeter. So half times 24 times the slant height. The slant height, which we found is 5, plus the base area, which was 36. Type that in a calculator. Bang, 96 meters squared. Square meters is how much it would take to cover the whole outside of this rootin' tootin' rectangular pyramid. Got another slant height, and I actually took the base and drew it off to the side for you this time so that you could kind of see me doing the Pythagorean theorem. So if I need to find the perimeter of this thing, because again, this is a triangular prism. So with prisms, I'm going to need the base perimeter. And in order to find that side there, I need to find kind of that slant height that's right there, that diagonal side. I need to know how far that side is. So I know that it's 7 up, and the whole thing was 8. So it's 4 and 4, because it comes again down right in the middle. So I can use 4 squared plus 7 squared, and then square root that to get about 8.06. So each of these sides here and here are about 8.06. And if I want to know the perimeter, I take 8 across the bottom plus 8.06 plus 8.06 and add those together. So a base perimeter is 24.12. The height then is just how far back it goes to the other base. That's 13. And the area of the base, again, it's a triangle, so you do 1/2 base times altitude. So half of the base times the altitude is going to give you 28. Half times 8 times 7. And now we've got all our pieces. The base perimeter, the height, and the base area. So you plug those numbers in to your equation to find this one. Base perimeter times its height plus 2 times the base area. Base perimeter times its height plus 2 times the base area, just using the numbers that we already found. Dump it in a calculator. 369.56 square centimeters. Woo! Moving right along. Again, we've got a diameter, so I had to split it in half. And again, find the slant height. So I've got 4 and 9. So I do 4 squared plus 9 squared and square root that to find the slant height is about 9.85. That's the slant height. The radius I know is 4. That's all you need for a cone is the radius and the slant height. So from there, I just start plugging in pi times the radius 4 times the slant height 9.85 plus pi times the radius squared 4 squared. Dump it in a calculator and you're on your way. Last one. Here we go. We've got that hemisphere again, half of a sphere. So now it's the same idea as volume. If I've got half the sphere, instead of having half the volume, I have half the surface area. If you cut a basketball in half, it would have half the surface area. It would be half as much. What was it made out of? Hide? Rubber? Whatever. It'd be half as much surface area as the whole thing. So I am, instead of doing the whole sphere, would be 4 pi r squared to find the surface area. I'm taking half of that, 4 pi radius squared. The radius is 6. I'm doing half of it because I only have half a sphere, right? So you had to be a little bit clever with that, just like with the volume where you're like, oh, I don't have the whole thing. I've only got half of it. So I'm going to cut it in half. Taking the surface area in half gives you that much surface area for the sphere. Spheres are easy. You just need the radius and you get your answer, right? Everything else is a constant in that equation. You just need the radius. Now, when we get into the cylinder, we need both the radius and the height. But here's the thing. When I plug that into the cylinder, I got my radius and height. But then notice I added pi r squared, not 2 pi r squared. Take a second and think about why I might have done that, only adding pi r squared and not 2 pi r squared. Well, pi r squared is how you find the area here and here. But this area up at the top of the cylinder is being covered by the sphere, so that wouldn't be part of the surface. That's part of the interior. This is not part of surface area. It's not on the outside. So that's why it's 2 pi r squared, is because normally a cylinder has an area up here and an area down there. But if this is being covered by something else, now I only need pi r squared to be added on. This part gives you the surface area around the outside, right here. This is what gives you the top and bottom area. I only want the bottom, so I dropped the 2. Again, if you did that, woozy daisy, you can have my job. Plug that all in to a calculator and get 603.19. So this is the surface area of the cylinder. This is the surface area of the hemisphere. Add them together to get a total surface area of 829.38 square inches. Good golly, Miss Molly, surface area is a doozy. What year is this? I sound like I'm from the 1800s. Great job. I'm exhausted. That was a lot. If you have questions, I expect you do. Please, please, please reach out. It's just about finding the variables and dumping them into the appropriate equation. It's not that bad, but it's kind of bad. So take your time, spend lots and lots of time practicing this, and as always, ask when you have questions.